Hi guys, welcome back. We are going to finish the chapter today. We're going to cover both sections B and C, kind of a short chapter. It's nice. So we're going to talk about mechanical energy. Let me move myself up here for now. Mechanical energy is the sum total of all the kinetic and potential energy in a system. Okay, so back to my baseball. When I'm holding it, it's actually got potential energy, but I'm not going to drop it, so I'm going to kind of discount that. As soon as I throw it, it's moving, so it's demonstrating kinetic energy. It stops at its maximum height, and it for a brief second, even less than that, it's not moving, so there's really no kinetic energy, but it's got all kinds of potential energy to it, and that's what brings it back down. So we've got kinetic transferring into potential, and then potential transferring back into kinetic as it comes back down. Okay. If the system is not closed, we don't say we lose the energy, but some of the energy might actually be transferred to friction or air resistance or things like that. Okay, so let's look at this pendulum. We've got the first step right there. If I'm holding the ball out there, it would have potential energy. As soon as I let go, it's going to start moving, right? So that potential energy is being transferred into kinetic energy. Once it gets to its lowest point right here, there's no more potential energy. So this would be 100% kinetic energy down at the bottom, okay? And that kinetic energy is now what carries it back up opposite of gravity. It gives it enough of that momentum to keep it going, okay? But as it's moving up, that kinetic energy is turning back into potential energy, okay? The ball will stop for a split second right there, and so it has all potential energy, no kinetic. But we all know it's going to swing back this way. And so there's a constant transformation between that potential and kinetic energy. And just that movement of the object is kind of referred to as mechanical energy, okay? Some of the things that you can transfer that energy to would be sound, okay? If you listen when I catch this, okay? It makes noise. Sound is a form of energy. Okay, so if anything makes noise, you're actually transferring some of the energy into sound. And then obviously friction and heat. Friction causes heat. Friction itself isn't energy, but whenever there's friction, there's a lot of heat, and so the energy is being transferred into the particles around it. When this ball slams into the counter, that's a lot of friction. And it actually causes heat, and it causes the particles of the counter to move, to vibrate faster than they were. Some of the energy, the kinetic energy from the ball, got transferred into the counter. Okay. All right, let me bring myself back down here. All right. So energy is transformed beyond just kinetic and potential energy. Okay, there's lots of different types of energy. Sound energy we talked about, heat energy. The chemical energy, the energy that's absorbed and released in those reactions. Electrical energy, anything that you plug in is using electricity. That's a form of energy. Nuclear energy is stored in the nucleus of certain, all elements, but some have more of it than others. Light is a form of energy, and then electromagnetic energy. And we can transfer back and forth from these different types, okay? Almost all of this energy can be traced back to the sun, though. Not so much nuclear energy. Nuclear energy comes from elements like metals like uranium, which are mined out of the ground, and then it undergoes a process and releases energy. Okay, but almost all the other kinds of energy can be traced back to the sun. So, for instance, let's look at this hydropower dam here. Okay, and you can see these power lines. Let's assume those power lines are feeding off to your house where you've got your PlayStation plugged in, okay, your TV or whatever, all right? So where does the energy come from? And it might not come from a hydroelectric dam. It might come from a power plant that burns fossil fuels, okay? But the idea is the same. So the way a hydroelectric dam works is there's water stored behind a dam. That water has potential energy, okay? But that's still not back to the sun. So we have to talk about where that water came from, okay? Well, that water comes from rain. The rain is part of the water cycle. Guess what drives the water cycle? The sun, okay? So the water is there because of the sun, because of evaporation and precipitation and all that stuff. But as it's being held back by that dam, it's got potential energy. Once this control gate opens, the water can flow, demonstrating kinetic energy, and it turns this turbine right here, okay? So the kinetic energy of the water causes the turbine to turn with kinetic energy. That moves all these mechanisms in here inside of a generator. And there's magnets and there's copper and there's all kinds of stuff. And the movement of those materials transfers that kinetic energy into electrical energy, okay? That electrical energy can then travel along these power lines, and then you plug in your PlayStation or your TV or whatever it is, and it uses that electricity. And so when you are using that stuff, it's still from the sun. If this was a fossil fuel power plant, the fossil fuels came from the sun anyway, because fossil fuels that we'll talk about here in just a second are plants and animals that get their energy from the sun. So we'll talk more about that in a second. Right now, actually, non-renewable resources. These are energy sources that can't be replaced naturally, at least in a normal time frame, not within like a human lifespan. Okay, so the majority of natural resources are considered fossil fuels. Okay, and over 85% of all of the world's energy needs right now are being met by these non-renewable resources. Okay, so the fossil fuels include coal, natural gas, and then specifically oil, okay? Those were all formed a long, long, long time ago by dead plants and animals, okay? Now, secular scientists believe that's part of why the earth has to be so old, because this process took so long. Creation scientists, people that use the biblical worldview, believe that the flood did this. So when all those plants were destroyed and all those animals were destroyed, they were all buried under layers of sediment. That time and that pressure converted those organic things into fossil fuels. Okay, so it's a form of carbon that has this stored energy in it. Okay, well, plants we know perform photosynthesis, right? They convert the sun's energy into a storable source of energy for themselves, and then we eat that. Okay, or animals eat the plants that get the energy from the sun. So these plants, these power plants that burn fossil fuels, it still can be traced back to the sun. Okay. Nuclear energy is also considered a non-renewable source, just because it requires mining these special metals out of the ground, and then it produces energy with a fission reaction, and it's very clean. There's no air pollution, but it's very risky. If the power plant has a meltdown, then the radioactivity of these materials can get out and can cause huge environmental problems. The entire city of Chernobyl to this day is still shut down from an accident in the 80s. There was a big power plant, a big nuclear plant in Japan with that big quake back in, what was it, 2011 or 01, or it was a while ago now. They had 3 of their units melt down, and it got into the ocean, and it caused a big problem. So these nuclear power plants, unfortunately, are kind of scary. There's so much energy. Like, we would not probably run out of energy if we could really rely on nuclear energy. There's so much energy stored in these materials. Okay, we also have renewable sources. So renewable resources are easily replaced by natural methods. The problem is that they don't meet quite enough of the needs. Okay, so here's several examples of these renewable sources. Okay, biomass energy is just like plants. People burn animal poop. That would be considered a biomass. Biodiesel. People take grease from restaurants and can convert it into fuel. Those would all be examples of a biomass. Okay, the hydroelectric. That's the water moving through the dam that I told you about. Geothermal, I don't know if you remember back to 6th grade science, the Earth's mantle and like geysers and things like that. There's lots of heat underground, and that heat gets up to the surface in different places and can be trapped and converted into like electricity, or just the heat can be used to heat people's homes. Solar, obviously you see solar powers everywhere, solar panels everywhere. Even cars sometimes have solar panels on them now. This is a solar array. This is a crazy contraption. You might have seen this on the way to Las Vegas. These are not solar panels. It's still using solar energy though. These are mirrors, okay? And so the mirrors are reflecting the sun up into this unit up top here. And it's heating water to create steam, and it's like a steam engine, and it produces electricity that way. We're going to talk a little bit more about that, because while that's a good, clean way of capturing the sun's energy, and there's plenty of it, it doesn't come without its problems. Windmills, the wind is going to blow, and if it turns the blades, same thing. It's like turning the turbine in a dam. And there's also tidal energy. There's tidal power plants that take the incoming high tide, and then the changing to the low tide, the movement of that water, they can convert to energy. So there's pros and cons to this, right? A lot of these renewable sources are considered clean energy, and we need clean energy because air pollution is a big problem. And there's a lot of it. I mean, we're always going to have wind. The sun's not going anywhere anytime soon. We've got plenty of water. So it seems like we'd have plenty of it. It could be very expensive, though, to build the power plants that we need to convert these natural resources into energy. It can be very expensive. Plus, they're not super efficient. It might not produce quite enough to cover the needs of the people. And there's still a lot of environmental concerns with it. This is an abandoned hydroelectric dam. Like, now there's just all this concrete there out in nature. There was, a flowing river there that a dam was built on it, and that'd be great if it produces electricity. But if it's not taken care of, if it's, run down or whatever, it's now kind of altered the environment there. That mirror thing in Vegas that I was showing you, it displaced all kinds of desert tortoises when they built it. But like hundreds of birds die every year because as the sun is getting reflected back up to that center portion, it heats the air over 1,000 degrees. And if a bird happens to fly through it, it's like poof, the bird's gone. And so while it might reduce air pollution, there's always other environmental impacts to these. If you build a tidal power plant, it takes up a huge section of the beach, and then there goes the ecology of the beach. Okay, so the biggest thing we could do is conserve. Conservation is the key. It's the responsible thing to do. Turn your lights off. Use LED lights instead of incandescent bulbs. Don't plug in 25 things. Just try to reduce as much as possible, because the less our energy needs are, the less we'll need to produce all this stuff to cover it. Okay, so be good people. Bye-bye.